Welcome to GeoVenture. Please like and subscribe for more. People often ask a question that seems torn from the pages of a science fiction nightmare. It's a question whispered with a mix of awe and genuine fear. Could a black hole ever find its way to our little blue planet and destroy us? The very idea conjures images of an inescapable cosmic void, a silent predator lurking in the vast darkness of space, ready to swallow our world whole. It's a deep primal fear of the unknown, a force so powerful that it defies our everyday understanding of the universe. But the universe, while vast and mysterious, also operates on principles we can understand. Science is our tool, our flashlight in the dark. We can use it to replace fear with knowledge. Instead of letting our imaginations run wild with doomsday scenarios, we can look at the simple, observable facts. We will journey into the heart of this question, demystifying these cosmic behemoths. What black holes are, how they could theoretically pose a threat, and why you can sleep soundly at night. The real story is one of immense distances, predictable physics, and the reassuring emptiness of space, our quiet cosmic neighborhood, far from the galaxy's chaotic downtown. So, what is a black hole? Let's strip away the science fiction and get to the core concept. Imagine you throw a ball into the air. Gravity pulls it back down. Throw it hard enough and it escapes Earth, about 25,000 miles per hour. A black hole is a region where escape speed exceeds light. Nothing travels faster than light, so nothing can escape. We can't see it directly. It's a perfect cosmic silhouette. So how do we know they're there? We see their effects. Stars orbiting in unseen mass, gas heating as it spirals inward, then disappearing over the edge, the event horizon, the point of no return. They're born when truly massive stars die. Outer layers explode as a supernova, while the core implodes into a singularity, a permanent wrinkle in space-time. Black holes aren't galaxy-wide vacuum cleaners. From a distance, their gravity is like any object of equal mass. Replace the sun with a same-mass black hole. Planetary orbits barely change. It would be very cold and dark, but we wouldn't be suddenly sucked in. You only get in trouble when you get very, very close. Black holes are not all created equal. They come in a fascinating range of sizes. The smallest we've found, stellar mass, formed from the collapse of massive stars, weighing roughly 5 to 20 suns, squeezed into a space a few miles across. Imagine cramming several suns into a single city. That's mind-boggling density. These silent remnants wander the galaxy. Then come the giants, supermassive black holes, millions to billions of solar masses, at the heart of most galaxies, including our Milky Way. Ours is Sagittarius A, about 4 million suns in mass, and roughly 26,000 light-years away. That unimaginably vast distance makes its pull on us negligible. Like worrying a candle in another country will burn your house down. There's a theoretical third category, primordial black holes, perhaps as massive as a mountain, yet smaller than an atom. Intriguing, potentially solving cosmic puzzles, but not confirmed. Could a rogue black hole drifting in the dark stumble into our solar system? Let's look at the odds. The probability is astronomically low. Space is spacious, overwhelmingly, stupefyingly empty. Stars are like scattered grains of sand in a globe-spanning desert. For danger, a rogue would need a needle-in-a-haystack trajectory aimed directly at our tiny solar system. The galaxy spans 100,000 light-years with hundreds of billions of stars and perhaps millions of black holes dispersed across an immense volume. A close encounter is vanishingly unlikely. If one passed through the Oort cloud, it might nudge comets. Some could drift inward over thousands of years. Noticeable, not immediate catastrophe. To rip planets from orbits, it must pass inside Neptune, and such a massive visitor wouldn't sneak up. We'd see outer planets wobble years, even decades beforehand. Astronomers track positions meticulously. Any deviation is a red flag. It wouldn't be a surprise attack from the dark. What if a black hole came close enough to swallow Earth, crossing the event horizon, the one-way boundary of no return? A sun-mass black hole's horizon is only 3.7 miles across. Earth is 8,000 miles wide. A direct hit requires an incredibly precise, unlikely collision. Long before a collision, extreme tides strike. Like the moon raises our oceans, a black hole's gravity pulls far harder on the near side than the far side, stretching Earth. Earth would be torn apart, spaghettification, our world transformed into superheated debris spiraling into a blazing accretion disk. For a typical stellar mass black hole, the tidal danger zone is within a few 100,000 miles. On cosmic scales, a hair's breadth, requiring an almost impossibly exact path. Again, not without warning, such mass would reveal itself by perturbing planetary orbits, Jupiter, Saturn, Uranus, Neptune, long before reaching Earth. The danger isn't that it could happen tomorrow, it's that within humanity's lifetime it is so profoundly unlikely it borders on impossible. What about hypothetical primordial black holes? The tiny ones from the dawn of time. Could one zip through space and hit Earth? A mountain mass black hole would be smaller than a proton. If it struck Earth, it would pass straight through, interacting with almost nothing. Our atoms are mostly empty space. Its gravitational reach is minuscule, transit under a second, no time to accrete, no chance to get stuck or start consuming the planet. A cosmic bullet passing through, not a seed of destruction. Could the sun become a black hole and doom us? A definitive no. Forming a black hole demands immense mass. The sun is far too light. End-of-life black holes come from stars, and 20 times the sun's mass. In over 5 billion years, the sun swells into a red giant, likely engulfing Mercury, Venus, possibly Earth, then sheds its layers, leaving a white dwarf to fade over trillions of years. No black hole involved. Dramatic, yes, but not a black hole story. The conclusion is overwhelmingly clear. The danger to Earth from a black hole is practically zero, dwarfed by countless more realistic concerns. Vast stellar separations, predictable gravity, and the sheer emptiness of space. We are not in a shooting gallery. We live in a quiet, stable corner of the galaxy. This isn't wishful thinking, it's observation and calculation. Astronomers map the heavens with ever more powerful surveys. Pan-STARRS and the Vera C. Rubin Observatory are built to catch moving and changing objects. A massive, dark intruder would betray itself gravitationally. Science lets us see things coming and we see nothing. Black holes aren't assassins, they're engines of galaxies, endpoints of giant stars, and laboratories for gravity. Look up with peace and curiosity. Real risks are closer to home: climate, disease, sustainability, while black holes continue their silent, distant dance as we thrive on this safe, beautiful world.